In 2023, a team of researchers published a satellite image. It was not classified, it was not hidden. It was uploaded to a public NASA database, available to anyone with an internet connection. And almost nobody noticed. The image showed something beneath 2 miles of Antarctic ice. Not a geological formation anyone had predicted. Not a result that matched the models. Something that, when you look at it carefully, raises a question that the researchers themselves did not answer in their paper. That question is what this video is about. We are not going to tell you that aliens built a city under the ice. We are not going to show you blurry screenshots and ask you to squint. What we are going to do is walk through the actual data layer by layer, the same way a geologist would. And at the end, you are going to see exactly why this image stopped several very serious scientists in their tracks. Stay with us, because the further we go into this, the stranger it gets. Antarctica is the most isolated place on Earth. It is larger than Europe. It is colder than anything most humans will ever experience. For most of human history, we assumed it was simply a blank, frozen, dead continent sitting at the bottom of the world. That assumption started cracking in 1958, when the first radar surveys were flown over the ice sheet. Scientists bounced radio waves off the surface and watched them travel down through the ice, hit something solid, and bounce back. What they expected to find was bedrock, flat, ancient, boring bedrock. What they found instead was a landscape, mountains taller than the Alps, valleys deeper than the Grand Canyon, a hidden world sitting underneath 2 miles of frozen water, completely invisible from the surface. And here is the thing that most people skip over when they hear this. That landscape did not form under ice. Ice does not carve mountains. Ice does not create river valleys with the specific curved shape that radar was showing. Those shapes are made by liquid water, by rivers, by rain, by a climate that is nothing like what exists in Antarctica today. Whatever is under that ice was shaped by a world that no longer exists. And the question of when that world ended is where this investigation starts to get genuinely uncomfortable. Let us start with the publicly available data, because that is the most important part of this. Everything we are about to go through can be verified. All of it is sourced from institutions like NASA, the British Antarctic Survey, and the Alfred Wegener Institute. We are not working from anonymous claims or fringe websites. We are working from peer-reviewed papers and public databases. The project that produced the image from 2023 is called BedMachine Antarctica. It is a collaboration between dozens of research institutions across multiple countries. Its goal is to map the bedrock beneath the Antarctic ice sheet with the highest possible resolution. Researchers combine satellite gravity data, airborne radar, seismic measurements, and ice core samples. They feed all of that into a model, and the model produces a picture of what the continent looks like without the ice. The 2023 update to BedMachine was significant because the resolution jumped dramatically. Earlier versions could show features roughly the size of a small city. The new version can resolve features the size of a few city blocks. And when that resolution increased, something appeared that had not been visible before. In the Wilkes Land region of East Antarctica, beneath approximately 2.7 kilometers of ice, the new data revealed a formation that does not match the surrounding geology. The bedrock in that region is ancient. We are talking about rock that has not been significantly altered in hundreds of millions of years, except in this one area. In an area roughly 120 kilometers across, the bedrock shows a pattern of regularity that geologists flagged immediately. Not perfectly regular, not geometric in a way that would make you immediately say something artificial is going on. but regular enough that the lead researchers noted it explicitly in their paper as requiring further investigation. Their exact words were that the formation showed anomalous internal structure inconsistent with known glacial or tectonic processes in the region. That sentence was published in a peer-reviewed journal. It is sitting in the public record right now. And almost no one outside of the geology community read it. Now, before we go further, we need to be precise about what that means and what it does not mean. Anomalous does not mean impossible. It does not mean artificial. Geology is full of formations that look strange until someone finds the mechanism that explains them. Crater fields, volcanic intrusions, ancient impact sites, all of these can produce patterns that look irregular or unexpectedly ordered. What it does mean is that the standard explanations do not fit. And that is exactly the kind of situation where the investigation gets interesting. If you are finding this useful, hit the like button right now. It genuinely helps this channel reach people who are looking for exactly this kind of sourced, careful breakdown. Now let us keep going, because we are just getting to the part where the data starts to stack up. To understand why that formation in Wilkes Land is strange, you need to understand what the rest of the Antarctic bedrock looks like. Antarctica was not always where it is. 250 million years ago, it was part of a supercontinent called Gondwana. It sat at a much warmer latitude, covered in forests, home to rivers and lakes, and a rich variety of life. The fossils are there to prove it. Researchers have found the remains of temperate forests in Antarctica. They have found dinosaur bones. They have found evidence of a lush, functioning ecosystem in a place that today sees temperatures of -60 degrees Celsius. Then the continent drifted. It moved toward the pole over tens of millions of years. As it did, it cooled. The ice sheets began to form, slowly at first, then rapidly, until the entire continent was buried under what is now the largest single mass of ice on Earth. The major glaciation of Antarctica began around 34 million years ago. It accelerated around 14 million years ago, which means that everything underneath that ice was exposed to a surface environment for a very long time before the ice covered it. This is critical to understanding the Wilkes Land anomaly. The geological record from that period in Antarctica is, compared to other continents, extremely sparse. We cannot dig, we cannot sample widely. We are almost entirely dependent on what radar and gravity sensors can tell us from above, which means there is a lot we simply do not know. Here is where the investigation shifts from the geology to the physics. Antarctica has a gravitational anomaly. Actually, it has several. The continent's ice mass is so enormous that it depresses the bedrock beneath it. As the ice shifts and melts, the bedrock slowly rebounds. This is well understood and well modeled. But in specific regions of Antarctica, the gravity readings do not match the models even after accounting for the ice load and the bedrock rebound. One of those regions is Wilkes Land. In 2006, a paper published in Earth and Planetary Science Letters described a significant mascon beneath the Wilkes Land ice sheet. A mascon is a region where there is more mass than the surrounding geology would predict. They are common on the Moon. They form when large impacts bring dense material from deep in a planet's interior close to the surface. On Earth, they are rarer, but they exist. The leading explanation for the Wilkes Land mascon is an ancient impact crater. If that interpretation is correct, beneath the ice in Wilkes Land sits one of the largest impact craters on Earth, possibly the largest. Roughly 500 kilometers across, formed approximately 250 million years ago, right at the boundary between the Permian and Triassic periods. That boundary is known as the Great Dying, the largest extinction event in the history of complex life on Earth. 96% of marine species, 70% of terrestrial vertebrates, gone. The Wilkes Land impactor, if confirmed, would have been large enough to trigger the kind of environmental catastrophe consistent with that extinction. And the timing matches. This is not a fringe theory. This is a serious scientific hypothesis discussed in the literature for nearly 2 decades. And yet almost no one outside the scientific community knows it exists. But here is where we come back to the 2023 BedMachine data. The anomalous internal structure that the researchers flagged is located within the area that corresponds to the proposed crater. Impact craters, when they are large enough, do not just leave a circular scar. They produce a specific pattern of geological disruption: shatter cones, shocked quartz, uplifted central peaks. The pattern the 2023 data shows is consistent with some of those features. Not all of them, not definitively, but enough that the researchers felt it warranted specific mention in a peer-reviewed paper. So what we have, when we stack it up, is this: a region of Antarctica with anomalous bedrock structure, a gravitational signature indicating unusual mass concentration, a proposed impact crater of enormous size, a timing that coincides with the largest extinction in Earth's history, and a new dataset showing internal structure that current models cannot fully explain. None of that proves anything unusual is happening, but all of it points to the same location. And that is the kind of convergence that makes geologists very interested and very careful about what they say publicly. Now we need to talk about what the ice itself is hiding. Subscribe to this channel if you are not already, because this is the kind of investigation we do here. Not speculation, not hype, just data stacked carefully with the questions that data actually raises. Beneath the Antarctic ice sheet, there is liquid water. In specific locations, the heat from the Earth's interior, combined with the insulating pressure of kilometers of ice above, creates conditions warm enough to melt the base of the ice sheet. This produces what are called subglacial lakes. We have mapped over 400 of them so far. The most famous is Lake Vostok, which sits beneath nearly 4 kilometers of ice and is roughly the size of Lake Ontario. In the Wilkes Land region, there are several mapped subglacial lakes. 2 of those lakes sit directly above the area of anomalous bedrock structure. Their positions correspond with what would be the central uplift region of the proposed impact crater. Impact craters can concentrate geothermal heat in ways that promote subglacial melting. This is a known phenomenon, but it means that the water in those lakes has been sitting in contact with that anomalous bedrock, potentially for millions of years. And lake water isolated beneath kilometers of ice for millions of years is one of the most interesting and least understood things on Earth. Samples from Lake Vostok, extracted through ice cores, have already revealed microbial life. Life adapted to conditions of extreme cold, pressure, and darkness. Life that has been evolving in isolation, with no sunlight, no contact with the surface world, for somewhere between 15 and 34 million years. What is in the Wilkes Land lakes? We do not know. No one has sampled them. The logistics of drilling through nearly 3 kilometers of ice to reach a body of liquid water without contaminating it are enormous. There are plans, there are proposals, but no samples have been extracted. So we have ancient, isolated water, we have anomalous bedrock, we have a potential crater from the largest extinction event in complex life's history, and we have a dataset that shows internal geological structure that the researchers themselves say they cannot yet explain. That is where the investigation currently sits. Now, let us talk about the history of scientific attention on this region. The Wilkes Land anomaly has been known in one form or another since the 1960s. Early gravity surveys flagged the region as unusual. Subsequent radar surveys confirmed unusual bedrock topography. The 2006 paper on the mascon brought it to wider attention within the geophysical community. But the amount of dedicated investigation relative to the scale of what might be there is, to put it generously, modest. Antarctica is enormous. Resources are limited. Getting equipment to Wilkes Land, which sits in the most remote part of an already maximally remote continent, requires enormous logistical effort. The research that has been done has largely been done as part of broader surveys, not as dedicated investigation of this specific location. What that means practically is that the data we have is good enough to identify that something interesting is there, but not yet good enough to tell us definitively what it is. The 2023 BedMachine update was the most significant increase in resolution we have seen. It revealed the anomalous internal structure for the first time. The next major dataset, expected from ESA's Cryosat mission updates and from a planned NASA airborne survey, could increase resolution further. When that data arrives, some of these questions may get answers, or the picture may get more complicated. That is how geology usually works. Every answer opens two new questions. The continent has been under ice for 34 million years. The record it contains of climate, of impacts, of biology is unlike anything accessible anywhere else on Earth, and we have barely started reading it. So where does that leave us? We started with a satellite image that almost nobody noticed. We followed the data through bedrock anomalies and gravitational signatures and subglacial lakes and ancient extinction events. We looked at what the researchers actually wrote in their actual papers, and we found a pattern of convergence around a single region that the scientists studying it openly describe as not yet fully understood. There is no clean conclusion here. There is not supposed to be. The data does not give us one yet. What it gives us is a location, a set of measurements that do not entirely fit existing models, and a formal scientific acknowledgement that further investigation is needed. The question of what is actually down there, under 3 kilometers of ice in one of the most inaccessible places on Earth, is genuinely open. The researchers who know this data best are the ones who are most careful about saying what it means. That carefulness is not evasion. It is exactly what good science looks like when it is standing at the edge of something it does not yet understand. If the next survey confirms the crater structure, we will have a new understanding of the Great Dying and of how large impacts reshape planetary geology over millions of years. If the bedrock anomalies turn out to have a different explanation entirely, that explanation will itself be significant. There is no version of this where the answer is boring. And if you think about what it means that this conversation about publicly available data from major research institutions has barely reached anyone outside of specialist literature, that itself is worth sitting with. The data is public. The questions are real. The investigation is ongoing. And for now, 2 miles below the surface of the most isolated continent on Earth, whatever is down there is still waiting. Drop a comment below. Tell us what you think the most likely explanation is. We read every comment, and the best answers usually come from people who have been following this kind of research independently. We will see you in the next one.